Okay, this is number 6 on the Chapter 11 Part 1 review. This is non-calculator. It's the free response for the non-calculator section. So on Part A, we are asked to determine whether this series converges or diverges and to justify, which means we're going to have to follow through and make sure we have all the parts of the test that we're supposed to have. So I think, just right off the bat, I think this thing diverges because it's going to act like 1 over n. And I'm going to do a limit comparison because that's what I prefer. So I'm going to just write, we're going to compare to, and don't just write 1 over n, because 1 over n actually is not a series. We have to have that sigma notation to know if that is a series. So we're going to compare to that, which diverges by p series. And then I'm going to do limit as n approaches infinity. And I'm going to be very careful about this to make sure I have it all right. So the one we're interested in over the one we have. No shortcuts. So flip that. I think at this point you could say 4, but I'm just going to write one more line here. So we have 4n squared over n squared plus 1, which is 4. I'm going to just say, which tells me the two series act the same. Now I'll make my conclusion here. So the one we're interested in, that they're calling A up there, diverges. Okay. And on part B, they're just wanting us to multiply here, and I think this is a fairly straightforward question. So if I take that 4n over n squared plus 1, and I multiply it by this 1 over 2n, it ends up being 2 over n squared plus 1. So I'm just going to rewrite that in official notation. I know it's because I have that earlier selected, it's going to be mad at me. So 2 over n squared plus 1. Hopefully it won't be too mad at me for leaving it that way. And then we want to know on C here if that converges or diverges. So I think, again, I can look at it and say it converges. It's going to act like 1 over n squared, but I'm going to go ahead and go through all that process. So I'm just going to write this series real quick. So it was 2 over n squared plus 1. Okay, so compare to 1 over n squared, which converges by p series. Okay. And then I'm going to use limit comparison to prove that's a good comparison. So the original over the one I'm comparing it to. So have that flipped. And again, I'm going to write one more limit statement here, which is 2. Again, we're looking for a positive number here. So I'm just going to say, which means they act the same. So that series I'm interested in, 2 over n squared plus 1, converges.